Hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing binary search. Following the next pattern, which is binary search on answers, we will do the next question, which is minimum number of days to make M bouquets. So let's read the problem statement. It says we will be given an integer array called Bloom Day and an integer M and K. Now let's see what is M and K. You want to make M bouquets. Okay, so M is nothing but the number of bouquets, and to make a bouquet you need to use K adjacent flowers from the garden. So Bloom Day actually represents the adjacent flowers in the garden, and we have to make M bouquets, and each bouquet should contain K flowers. Okay, so we have to return the minimum number of days we need to wait to be able to make M bouquets from the garden. So we have to return the minimum number of days. But why we have to wait? Because in the array it has been given the Bloom Day. If 1 is given, means you can pick that flower on the first day. If 10 is given, means you can pick the flower at 10th day. If you will come at 8th day or 9th day or 7th day, you cannot pick the flowers. Okay, means to pick the flower you have to wait for 10 days, correct? So this is the waiting period, and you have to return the minimum waiting days, after which you can actually make the M bouquets. So let's read the constraint. Constraint says Bloom Day length will be n, and n can go till 10 power 5 and it can be 1. Okay, so means at least there will be one flower. Bloom Day of I can go till 10 power 9. Bloom Day of I is an integer value, and integer value can go till 9. Okay, it is safe. And M is number of bouquets, and it can go till 10 power 6, and K is also as equal to the N. So let's come on to the screen. This is the array which we have been given. Okay, so if we come on the first day, we can pick this flower, but we cannot pick this, we cannot pick this. Now if we come on second day, we can pick this, we can not pick this, correct? Third day, we can pick this, we cannot pick this. If you feel we can pick this, you cannot, because the question says you have to make the bouquets of K flowers but adjacent flowers. Means if you pick this, you cannot pick this flower and keep in the same bouquet. No, you can pick this third flower for sure, but this flower you will keep in some another bouquet, and this 3 flower you can keep in some another bouquet. Why? Because for the first bouquet this 1 is obviously adjacent, and for second bouquet this 3 is adjacent. So means we have to return the minimum days now. So how you will try doing with brute force approach? Think. You will definitely try to hit and try, correct? So you will try to go on day 1 and you will see ki let's see how many flowers you can take. Okay, so the question says in this 1 flower is enough, but let's remove this and let's write 2 here. Let's try to make 3 bouquets with 2 flowers. What do you think? If you have to make 3 bouquets with 2 flowers each, how many minimum flowers you need? 6. Okay, and what is the length of this Bloom Day? Means Bloom Day means nothing but flowers, number of flowers. So if number of flowers are 5, so can you make 3 bouquets of 2 flowers each? Because for this so you need 6 flowers, na? So hence that is a base case. So means if your M into K is greater than the length of this Bloom Day, which is number of flowers, means you cannot make M bouquets, and hence you have to return -1. So that will be our base case, remember that. Okay, now the second important question is how would you like to hit and try, like with what value? So definitely you would like to go with day 1. Okay, let's go with first day. So if you will go on day 1, obviously you can pick this flower. So basically you need 2 flowers to make 1 bouquet, na? So let's initialize it with 0, and once you found what? The Bloom Day of I is less than equal to day, because you are going on first day, so you can pick this flower. Suppose you are going on second day. So definitely this flower says na ki hey, I will bloom on the first day itself. So if you are coming at second day, you can definitely pick me, correct? Because it is less than. So can I say ki if Bloom Day of I is what? Less than equal to the day for which you are checking, then we can definitely pick this flower because it is adjacent also. So we will increase our count plus, correct? So after increasing the count now, we have to check ki hey, is the number of flowers is equal to K? Why? Because if it is equal to K, then I can think of making bouquet, right? So hence after count plus, we have to check ki if our count is equal to K, then what we will do? We will make a bouquet. Okay, so let's say B. Let's denote bouquet with B. So we will do B++. Correct? Yes. And after that, definitely, if I'll say, suppose if k was 1 na, so definitely I picked this one flower. So I can say ki yes, number of flowers is 1 and the required flower was also 1. So let's increase the bouquet. Correct? Now next time, definitely you want to make the new bouquet, another bouquet, and for that you have to reinitialize your count na. Otherwise, the next flower will also get counted in the first flower itself. Correct? So hence we need to reinitialize our count variable with 0, and count is nothing but flowers. Okay? Okay. So what will happen? So in this case, suppose when k was 1 itself, correct? So you went on this, obviously with day 1 you went and you can pick this flower. Okay. You added and number of bouquets also 1. Now next time definitely you would like to go on second one. It will say, hey, I will bloom on 10th day, and as this 10 is not less than is equal to the required day, so I cannot pick this flower. Correct? So hence again I will move to the next one. So now I'll go to this day. So now this one also has not bloomed, so we cannot pick this flower as well, and now we'll move on to this. Again 10 we cannot pick. Now 2 is again greater than 1, means we are coming on first day and I want to pick that flower which will bloom on second day. How can I pick? Correct? So I'll go out of this, and now I can say that the number of what? The number of bouquets I made was only 1. So after coming out of this, I can say somewhere here na ki the number of bouquets I can return true if only if the B count is greater than equal to the required bouquets, which was M. Correct? Ki if I was able to make that, then it is possible. Correct? So I will return true there. Correct? Otherwise, I will go with the higher days. But what is the minimum day and maximum day we want to look here? Why minimum and maximum? Because forget about binary search. But even if you have to apply the basic logic, suppose there was no day 1, okay? Only day 10 to this. So do you think you should go on day 1? Do you think? Because you cannot pick a single flower from there, na? You cannot pick a single flower, okay? So definitely you would like to go on second day, at least second day. Because on day 1 it does not make sense. Correct? So can I say the lower value will be the minimum of bloom day? Yes. Suppose na in the whole bloom day array, the array says 5th day and come on 10th day. So do you think we should go on first day, second day, third day, fourth day? That will not make sense, because you will not be able to pick a single flower from there. Correct? So hence you will go with 5th day, which is nothing but minimum of bouquet. Now, what is the maximum value here? 10. So do you think on 11th day you should go and try? Because the question is asking to return the minimum waiting day, correct? So hence do you think it will make sense if you'll go on 11th day, 12th day, 13th day? No, because all flowers on 10th day itself would have bloomed na. So hence why to go beyond that? Why to wait for larger time? So the maximum waiting day I can say ki is nothing but 10. So hence the lower value will be 1. The lower value will be minimum of bloom day, and the maximum higher value will be the maximum of bloom day. So definitely I can initialize low is equal to minimum of bloom day and higher is equal to maximum of bloom day. Okay. Now as the question asks to return the minimum waiting day, and if you want to run the for loop, suppose from int d is equal to low and you want to run d less than high, less than equal to high. Correct? Now as you are running from lowest value na, so you would like to try with every d. So what you would like to try ki if call the function with what? D days, correct? Bloom day array m and k, correct? And if with this day it was possible, that will be our minimum value na, then return true. Why I said this? See, on the number line, okay, suppose from first day you are trying till 10th day. With 1 it was not possible, with 2 not possible, with 3 not possible, suppose with 4 it was possible, suppose. So definitely this is my minimum answer itself na. So hence when you are running from lower value to higher value, with whatever deed was possible, that will be my minimum answer. So hence there I have to return what? The bloom day it is asking for, right? So I will return the D itself, because that's what it is expecting. And we can close all of this in a function, that function where we will actually catch this d, whatever we are sending in the parameter d, bloom day, m and k. And in this function, was it possible or not? It depends on the bouquet number, correct? So we have to write here ki if the number of bouquets we made here is greater than equal to the required m, then we can simply return true. कि yes, it was possible, and if we will return true from this function, this if case will catch it, and now it will return the expected minimum day. And here we have to check for every ith index of bloom day. So we have to close this in a for loop for int I is equal to 0, I less than bloom day dot length and I plus plus. So what will be the time complexity? If you will see, this for loop is running for the bloom day length. And what is the constraint for bloom day length? N. N can go till 10 power 5. So 10 power 5 for this. If you will see the outer array, which is running from the lowest to highest, correct? So this highest depends what can be the maximum value there. And if you will check in the array, it's nothing but 10 power 9. So in total, this will take 10 power 9. And inside this, we are calling the another function, which is actually taking further 10 power 5. So in total 10 power 9 into 10 power 5, so 10 power 14. Definitely this will give us TLE. So how can we optimize this? We cannot reduce this if you can see this. Why? Because we have to go on every ith of bloom day and we have to check if we can pick that flower or not. So hence this 10 power 5 is must. Now let's see if we can reduce this or not. Because the question mentioned that highest value can go till 10 power 9 and we are running from a lower value to higher value. So on a number line from a lower value to higher value, definitely everything is sorted, and when everything is sorted we can apply binary search, right? So basically instead of randomly checking from a lower value to higher value, why not to actually apply the binary concept there, binary search concept from a lower value to higher value, calculate a mid value here. If with that mid value it was possible, means it was possible to make m bouquets within that mid days, mid is nothing but number of days, if it was possible, and as the question is asking give me the minimum number of days, so definitely we would like to save this mid answer, because going leftward we might not find our answer. So we will save it and we will move our higher pointer to mid minus 1, correct? Yes, and if with this mid it is not possible, so definitely we would like to go for the higher search. So then we will move our low pointer to mid plus 1. So why we are discussing like this? Because we have already solved multiple questions in our previous video following the pattern of binary search. So if you face difficulty in understanding this, so I will definitely recommend you to watch the very first and second video from this pattern, and then you will able to recognize why we are going so fast. Okay, so now if we are applying the binary concept here, so instead of 10 power 9, it will take logarithmic of 10 power 9 base 2. So definitely in total it will be 10 power 5, which is nothing but n, multiplied by logarithmic of 10 power 9 base 2. And hence this will be faster and will not give you TLE. So let's read the code here. Definitely we'll calculate the n, which is nothing but bloom day dot length. And as you remember, we checked for the base case if the number of like m multiplied by k is greater than n, means the number of flowers available in the bloom day is lesser than the expected one, so it is not possible to make that m bouquets, and hence we will return -1. Now why we have typecasted this in long? Because if you see here, m is nothing but 10 power 6 and k is nothing but n, which is 10 power 5. So when you will multiply this 10 power 5 and 10 power 6, it will become 10 power 11, and you know the limit of integer is still 10 power 9. So 10 power 11 it is not possible to store. So 10 power 11 is not possible in the integer, so hence we have to typecast this in a long format. Now we want our higher and lower, which is nothing but min and max. So for this we have to calculate the minimum in the entire bloom day and maximum in the entire bloom day. Now we'll run the for loop from minimum to maximum, and whenever it is possible to make in the function, then and there we will return that d, and that will be our minimum days, or else at the end we will return -1. Now let's see in the function what we are doing. We are actually initializing a count variable which will count the number of flowers, and this is a bouquets which will actually count the number of bouquets we have made so far. Now we'll run a for each loop for the bloom day, and we will check every bloom, which is nothing but bloom day of I. That will check if that is less than equal to the required day or the waiting day, then we can pick that flower. Then we will do count plus plus, and now we'll check if our count is exactly matching with the required number of flowers to be added in the bouquet. Then we will actually increase the bouquet count and we will reinitialize the count, because going forward we have to actually take the fresh flowers. Or else if you see here, if the bloom is not less than equal to day means, suppose here you are coming on the first day, so definitely you can pick this, but when you will come here, this is not less than, so hence in this case definitely you would like to go like move forward, but you cannot pick this flower anymore because that is not adjacent. So hence you have to actually reinitialize your count variable. So for that we are actually reinitializing. Why? Because the whatever previous flowers you have collected, that flower you cannot continue with to actually put in the bouquet. So hence you have to actually throw all the flowers whichever you have collected so far, and you have to reinitialize with the flowers. And at the end, if number of bouquets you have calculated with this minimum days, if it is possible, like if it is greater than equal to the required one, means it is possible, and when it is possible it will return true and we will return this. So this was our brute force code. Now this for loop, if you will change by actually running the binary search logic, then it will take the logarithmic time complexity, which you can see here. See, we have to return our answer, so that we will initialize with -1. And now we are applying the binary search logic. So definitely we will run the while loop until they crosses each other. And now we'll calculate the mid value. With that mid value, we'll call the function. If that returns true, means with that minimum days, it is possible. So when it is possible, we will store this in an answer variable. And now the question asks us to return the minimum days. So definitely we would like to search in the left half instead of the right half. So for that we will put our higher value towards mid -1. Or else when it is not possible, definitely the mid value is not our answer. So in that case, we will put our lower value towards mid +1. And at the end, whatever will be our answer, that we will return. So if it was not possible, definitely our answer variable will never get updated inside this. So at the end, we will return as it is -1, which is already stored in the answer variable. So now we can run this code. But wait, let me show you running the brute force code also. Let's try to submit this and you will see you will get TLE here, because the time complexity here is 10 power 14. And as you can see, we already got the TLE. Now let's see how it got fixed in the binary search. We have actually not changed anything. Instead of just running the for loop, we have added this in a while loop, and now it is taking the logarithmic time complexity, and hence it is passed. So here was your Java solution. I hope you understood. And here is your Python solution. If you are from Python background, I have written the same code with the same logic. If you understood that logic, so definitely you can submit this on your own. And here is your C++ code if in case you are from C++ background. So here is your final code. I hope you guys understood, and I will definitely recommend you all to submit this on your own, and please don't try to copy paste the code whatever I have written here. Now with this we can go in our sheet and we can mark the next question as to be submitted, and let me know if you also submitted and hit this tick button. So that's it guys, I hope you learned, and now you guys are able to apply the logic on your own, like how to decide the lower and higher value in the brute force also, or in the binary search on answer pattern also. Because the binary search and answer pattern is all about to actually finding the lower and higher value, and second one is to write the function. If the question asks for the minimum, if it is possible, we will go towards the left side, and if the question asks for the maximum, if it is possible, we will go towards the right side. So with this hope you all understood, I am winding up this session today, and if you like the video, please do like and subscribe the channel if you have not yet subscribed, and if you feel the playlist, the channel is helpful for you, then do recommend the channel to your friends also. And if in case you guys are new to this channel, we are actually following the pattern wise DSA sheet. We are doing each and every question mentioned in that sheet, and if you're not aware of this, the link is already in the description below. And if in case you want to connect with me on Instagram, LinkedIn, or any social media, all the connection links will be there in the description. If you guys have any recommendation, any doubt, do let me know in the comment section. That's it for this video. Let's meet in another video with some more interesting topics and questions. Till then, keep learning, take care of yourself and your family too.